Hello guys, welcome back to the channel. Let's solve another challenge today. Today we're gonna try to solve the problem number 200 from LeetCode, that is number of islands. Let's see what we are given. So we are given an m by n 2D binary grid, which represents a map of ones land and zeros water. And we need to return how many islands there are in this grid, right? An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. Let's say in the first example, we have 1, 1, 1, 1. All are connected. 4 ones are connected horizontally, and in this way, and vertically there are 3, 3. In the first scenario, we have one island, right? All the ones are connected, and there is no other one. In the second grid, we have 4 ones are connected. We cannot take the diagonal. We can only look at the either horizontal or the vertical, right? So there is one island, and there is one island. There is a single one, and there is a 2 horizontally connected. So basically, there are 3 islands total, right? So the constraints are m is the number of rows, right? N is the number of columns. Then number of rows and number of columns, it can range from 1 up to 300. And all the grid elements are either 0 or 1. Let's see and understand that in a whiteboard. Okay. So we are given this much larger grid, right? So the total number of rows, there are 1 up to 4 is the 5, right? And total number of columns, 8. So we need to count number of islands. You can see here, there is I colored this. So 1, 1, 1. This one is one island, right? And this is another island. We can see this visually in the grid, right? There is another island. There is another island, right? Total number of islands, disconnected islands from each other, right? There are 4, right? Here, total number of islands are 4. So how we can count this? How we can count this? The number of islands in the given grid, right? Let's see. There are 2 techniques that we can use. Either we can use DFS, right? Or we can use BFS, breadth first search, right? So right now for this explanation, I will try to explain the BFS. Then if it's not too long, then we can just try the DFS. So let's see. So the logic is simple. We start iterating from the beginning of the array. We start from here. Then we check if this array is, we start iterating from the first element in the grid, right? We check if it's 1. If it's 1, then we iteratively do the BFS, right? And the number of islands, let's say right now, the total number of islands I can say here initially, it is, let's say 0. Once I see the first one, I start iterating from 0, 0, right? Once I start iterating from the very first one, I see it's 1, right? Then I increase 1, this number of islands. Now what I need to do, I need to see and check the neighbors of this one, because I saw this is 1, right? Now I need to mark all of the neighboring cells as the part of the same island, right? What I do, I have this directions are given. This is up, because 0 is I call this x. This one is y. Y is vertical. X is horizontal. So 0, 1 means that I'm increasing y 1, right? And I will check. I will try to go up but right, I cannot go up because it's outside the boundary, right? So then I will go, the next one I will go down, right? This one is this is down, so again x and y. So I will go down. I will just initially I will take this one, I will add to the data structure Q. Then I will pop this Q. I will pop this Q and add its neighbors, right? I can go horizontal, I can go vertical, right? Then I can add this element will be 0, 1, right? 0, 1. Then another neighbor is 1, 0, right? I will add this 2 in the queue. Now, after, see, there is interesting thing, right? We need to make sure after we visit this cell, we need to mark this one as visited, right? We need to convert this cell to, all of the zeros are water, so we need to convert this one to water, right? We convert that one to water, which means like that's done. Like we are done visiting that cell. Then this two guys, this one and this one, I'm gonna add to the queue, right? Then I will this one popped, right? Pop. Now I will start popping this after I process this cell. Let's say 0, 1 is this one, right? After I process this cell, after popping, right? I will pop this and I will add its neighbors, right? How many neighbors it has? It has this neighbor, it has this neighbor, right? So this neighbor will be 0, 2, right? 0, 2, and this neighbor will be 1, 1, right? 1, 1. And this one popped. Then I will also label this one as visited, and I basically drown that part of the island into the water. I convert to water. Now, this is 1, 0, which is this guy, right? Then I will pop this. I will pop this from the queue. Then I will convert this to water, and I will add its two neighbor, right? It has two neighbor, which is 1, 1. 1, 1, I will see it's already in the queue, so I will not add, and I will add this one, which is 2, 0, right? 2, 0. So then I will just keep popping 0, 2, which is this one. I will pop this, right? I will pop from the queue, then I will convert this one to 0, and after I convert, then I need to add this one to the queue, right? If I add this one to the queue, it will be 1, 2, right? 1, 2. Then I will just pop this one, which is 1, 1, this, and I will also add this one, which is 2, 1, right? 2, 1. So I can clean this part of queue, but let's just be there. So then I will just, this one is 2, 0, right? Then this is 2, 0. Then I will convert this one to 0 after popping, right? Then I will pop 1, 2. I will pop this. Basically, then after when I pop this 1, 2, I also need to add this 1, 3, right? To the queue, 1, 3. And after I pop all of them, I will make sure that this is because we are doing this BFS. We need to make sure that this queue is empty, right? Once this queue is empty, then we just go to the next element, right? Because right now, after we marked all of the cells to 0, right? All of them we converted to water. After I convert to water, right now in my initial loop, I started from the very first element, right? I still need to go to here and here, all of them, right? I will check they are already 0, right? Because in my loop, I see that they are already 0, so I will not do. Then I will come here. Then I will do BFS for them, and I will convert them. After I come here, then I will increase the number of islands into 2. Then I will also convert all of them to water. Then I just keep iterating, like going through this entire grid. Then I will come here. Then as soon as I see another one, which is not part of other islands, then I will increase the number of islands into 3. Then I will also convert all of them to water, right? The zeros means water. Then I just keep going like this, and I will see another one. Then I will increase this one 4, and I will convert both of them. I run through BFS. I drown them, so there will not be any grid left, right? This is basically the BFS approach to count number of islands in this grid, and using this 4 directions that we are defining. So let's see the code. Okay, so this is a code. I initially I put this if grid doesn't exist, so we need to return the 0, right? Then here I am defining the number of rows, which is going to be the length of the grid, and number of columns is grid the 0, right? Number of columns. And the direction, I am also defining here the directions. The first one is up, and this one is down. The third one is left, and the fourth one is the right. These are the directions that we will be needing to do the BFS or DFS, right? So let's see. Now we need to initialize island count, right? Island count is, we're going to initialize to be 0. Now we need to start iterating from traversing from the first cell for row in range self num rows, right? And then for each column, for a column in range self num calls, right? So then what we need to do, we need to check if grid row and column is equal to 1. If it's 1, right? That 1 is basically the part of island, right? Then we need to do the BFS or DFS. In this case, I can call, BFS. In the BFS, I need to pass the grid, because we want the BFS to do maybe entire island, maybe all ones or all zeros. We want to traverse entire grid for that, right? Whichever it's 1. So grid, and we're gonna pass the row, we're gonna pass the column. Then here, what we need to do here initially, then we need to increase the island count, right? Island count, we're gonna increment by 1. Then at the end, all we need to do, we need to return island count, right? So this BFS, what it will be doing, it will be traversing all of the connected ones, and it will mark them as the part of the island, right? Now, for the time sake, I have written this BFS or DFS, and I will just walk through the code with you. Okay, this is a BFS. We are, as I said, we are passing the grid and a number of rows and a number of columns. I mean the column, which cell we are at, right? Then I'm adding that row and column, as I showed in the whiteboard, I'm adding that to the queue. Since the queue is not empty now, while queue, I'm popping that row and column from the queue, pop left, queue the pop left, and it gives me row and column. Now from the specific cell in the grid, I need to go up, down, left, and right in all 4 directions. Initially, I need to iterate through the direction, right? And initially, it goes to up, right? and it calculates the new row by adding that dx to the row and dy to the column. It computes the new column, right, and new row, and it checks if that computed new row is within the bounds of the grid, right? It may be outside of the grid, right? Then we don't really care, and we want to make sure that it stays within the grid, right? So this new row is within the grid, and the new column is within the grid, and the grid, the cell, and that specific cell in the grid on the new column and new row, it's 1. If it's 1, what we do, we mark that cell as visited and we drown that cell, right? We just mark them as visited and just, okay, 0 is water, just basically just drown that to the water, right? Then we add this cell, new row and new column, to the queue, because that is a neighbor of this row and column, and it's a part of the same island, right? Is a part of the same island, so that's why we add this to the queue, and we just keep iterating this until the queue is empty, which means that we market all of the connected ones within one island, and we drown them all to water. We basically mark them as water now, right? And we start traversing that grid again from the next cell until we find the next one, right here, next one, and we repeat this BFS again. And for our case, we repeated that for how many times? Four times, right? And you can see here, we have here one island. We ran that BFS for this specific island. Initially, we started with this, the first one. Then we just keep going through this each cell in the grid until we find this grid, right? I mean, this cell. Then we just do the BFS or DFS and label all of the remaining zeros, remaining ones to 0. Then we just keep going like this and like this, like this. Then here we find another one, we increment, we see another one, we increment. And yeah, that's it. And if the number of rows is m and number of column is n, the time complexity is going to be m times n, right? Time complexity is m times n. And because we are visiting each cell, right, in the grid, and the space complexity is just a queue, right? That's where we are storing this cell, row, and column, right? So this will do the explanation. BFS, I mostly concentrated on the BFS approach to count the number of islands in a given grid. Yeah, thank you guys for watching and staying until the end. I hope I'll see you guys in the next videos. Please like and subscribe to the channel if you want to see more of this kind of videos. Thank you.